This short video will be covering the chain concept with specific regard to open chain and closed chain exercises. I wanted to start this video looking at a couple definitions. I want to look at these two smaller definitions that I put underneath. These two definitions that I put underneath are the common everyday definitions that I think you would hear if you were to go and just ask a chiropractor or a physical therapist or a doctor or an athletic trainer, hey, what is an open chain or a closed chain exercise? I believe that these are the definitions that you are likely to hear. So the likely definition or the common definition of an open chain exercise is simply the distal segment is not fixed or it can move about freely. So the foot or the hand can move about in space easily. In contrast, a closed chain exercise, the distal segment is fixed or it's stuck. It is not freely movable. These definitions are good as we add and I think they're common for a reason. As we add a little bit of complexity or layering to this, I think you'll find that these definitions, they don't always fit nicely. All of our exercises and all of our activities don't nicely fit in these definitions. So I've included some other definitions that have come from people who have thought about this a lot more than I have, but I actually think they're pretty good. So an open chain exercise are those exercises which the force applied overcomes the resistance. So for example, if you pick up a weight or a box or a ball and you pick it up with your arms and your body and you're able to lift it, you're overcoming the resistance of the thing in your hands, making it an open chain exercise. In contrast, a closed chain exercise is an exercise that you cannot overcome the resistance that's applied. In general, making your body the thing that moves. So a couple easy pictures of this. We've got an open chain foot here. We've got a closed chain foot here. This is going to be the open chain foot. The resistance applied by this soccer ball, your foot will be able to overcome it, in theory, as long as it's not a cannonball, and that makes that an open chain exercise. A closed chain exercise is displayed here with a squat. Your feet are firmly planted. You're not going to move the whole earth, and so your body is the thing that moves, making this a closed chain exercise. Here's a few more that I wanted you to see. This is that example of the squat where you see your body is moving. I wanted to pause here. This is a good one of a closed chain. Your hands are planted in the ground. It's a push-up. This is a closed chain exercise. Your body is the thing that is moving. This is a closed chain exercise. Again, your body is the thing that is doing the moving as opposed to the machine. Here's one more open chain, the one I wanted to get to next. So the same exercise as the push-up. This is exercising the same muscles. However, now we're doing it in an open chain exercise. Now we're on our back. We've put the resistance in our hands. The force of our body is overcoming the resistance of the weights, making this an open chain exercise. So just finish that out. Coming back to the slides here, we're going to go down just a little bit. So I wanted to include a quick side note. I know this video isn't covering arthrokinematics, but I just wanted to include a side note. Up to this point, whenever we have discussed our arthrokinematics, we have generally been doing it in an open chain type of concept, where the foot or the hand is the thing doing the moving. Therefore, the distal bone is the one that has been moving, and that's been the one we use as our moving bone. However, we can have instances, plenty of instances, in closed chain environments where the distal bone is actually not the bone doing the moving. It's actually going to be the proximal bone. This is a nice example. So this is the example that we've been using thus far where the foot is moving. So we would use this knee as a concave rule. But just realize, when you sit down or when you go upstairs, the distal segment is not actually the moving bone. The moving bone is the proximal bone. That would be the femur. All that does is this changes this at the knee joint from a concave to a convex moving bone. All other principles apply. This just fits nicely here when we talk about chain concepts because In a closed chain environment, it's often the proximal bone in the joint that does the moving as opposed to the distal bone. Anyway, just a side note. Okay, so let's cruise down here. So, open and closed chain, why do we think about this? Why is it important? How can we apply it? So the practical significance. In a closed chain exercise, movement at one joint affects the other joints in the body. It's constant, it's consistent, it's predictable. Because of that, what happens at one joint may affect another joint. What happens at one muscle may affect a joint outside of the joint it actually acts on. This is a good example. You guys have probably heard about this if you're a runner or if you have spent time in a physical therapy clinic or with an athletic trainer or an occupational therapist. You know, a lot of times when someone comes into a clinic and they're having some type of a hip problem or a knee problem, sometimes the first place you don't necessarily look is the knee. Sometimes you need to look down lower in the chain. Is something happening at the ankle which is affecting the knee or the hip? This is that kinematic chain. Again, this is a constant predictable movement pattern that happens in a closed chain exercise. Another practical significance. Here's a thought question. And I've actually already alluded to this. Is it possible to impact movement at the knee with muscles at the ankle or the hip? If you think or if you said out loud, yes, you are correct, we can actually impact movement at different joints with muscles that actually don't act at that joint. Let's look at a quick example. Here's the soleus muscle. The soleus muscle does not cross the knee joint, as highlighted here in this image. What I want you to do real fast, go ahead and stand up with your knees slightly bent. Keep your feet firmly planted on the floor so that the soles of your feet remain in contact with the floor. And what I want you to do is I want you to try to contract your plantar flexors. So contract your soleus and see what happens. I'm doing it as I stand here recording this video. What I actually feel, I can feel that muscle contract. I'm not allowing my foot to go into plantar flexion. And what actually happens is my knee goes into extension. How could that be? I'm not actually contracting my quads, or I'm trying not to. I'm trying to not contract my quads, which we generally think of as our knee extenders. I'm trying to contract my soleus, which is causing knee extension. When you keep your feet firmly planted on the floor and you contract this soleus muscle, you can imagine a scenario where that soleus concentrically contracts, shortening, pulling the tibia posteriorly, causing knee flexion. This actually happens fairly frequently in the body. It especially happens in scenarios where someone displays muscle weakness at a specific joint. There is compensation patterns that can exist at the knee, at the hip, at the shoulder. Anytime someone has a weak muscle, they can use other muscles in closed chain scenarios to overcome a muscle weakness to accomplish osteokinematic movement. So, a couple principles for this muscle substitution pattern. And remember, this is only in a closed chain scenario. State the primary action of the muscle. In the soleus muscle, this is actually plantar flexion. But then we state the condition, always closed chain. State the concurrent motions. So again, at this point, you have to just think, okay, I can accomplish plantar flexion. So when that muscle shortens, what is going to be the resulting motion? And in this instance, it's going to be knee extension. That soleus pulls posteriorly on the tibia, causing knee extension. And that's our concluding pattern of substitution. One final thought as I finish this video about open and closed chain kinetic exercise. In the real world, it's not always as simple as the definitions that we make it, which is why I included those other definitions from people who have thought about this more than I have. A nice example here is biking. So I've slowed this down so we can see it. You know, biking, thinking about our simple definition, the distal end is freely movable. In this biking instance, you could argue both ways. The foot is actually the thing that's moving. The body the body is causing enough force to achieve propulsion and movement, right? The body is not actually the thing doing the movement. The legs are enacting on the bike, which is causing the movement. So in that sense, this is an open chain exercise. However, I also could see that there's an argument that this is a closed chain exercise because the motion here is predictable, it's constant, it's consistent, it's repetitive, it's something that doesn't change. What happens at the ankle happens at the knee. And so I think there's arguments in this instance both ways, where this, you could view this as an open chain exercise, you could view it as a closed chain exercise, and I think as long as you can make your argument one way or the other, I think you're correct. But I think it's nice to include those other definitions just because in thinking that way, we're able to help further rationalize our theories as to why this may be an open chain or a closed chain exercise.